Hello everyone. Previously we had discussed on the ternary search algorithm, right? So we'll be discussing about this one, exponential search algorithm today, right? So let's finish it off with the exponential search algorithm within searching algorithms, right? So next we'll be moving on with the linked list algorithms. For now, let's finish it off with the exponential search algorithm, right? So let's get into the definition part first. So yeah, what the definition part say here, exponential search is a searching algorithm used to find the position of the target element. So basically it's similar to the searching algorithms, right? So basically it is used to find the position of the target element in the sorted array, right? And the sorted array, this is very important, right? So it works by exponentially increasing the search bound and then applying the binary search within that particular bound, right? So this is very important. It works by exponentially increasing the search bound and applying the binary search within that particular bound, right? So this is fine, I believe. Next, let's move on with the explanation part. So whatever we discuss here, the same thing will be implementing in the form of code or the algo, right? So by making use of the Python programming language, this is fine. Now let's move on with the step one. Here we will start from the index 1, the first index, right? So we'll start from the index 1, nothing but that will be 0 based. Basically it will be 0th index, right? So we'll start from the index 1 and keep doubling that index. See here, this one, 1 2 4 8 16 32, like that it goes on, right? So this is fine until the element at the index is greater than or equal to the target. So until what we do, until the element at the index is greater than or equal to the target, or until we go out of the bounds, particular bound, right? Or the bounds, right? So this is fine, I believe. So the next step is, once we find the range, nothing but the previous or the current where the target may exist, we will apply binary search within that range, right? So once we have that particular range, right, so once we get that range, then what we'll do, we will apply the binary search within this particular range, right? So just keep this in mind, this is very important. And if the target value is found, then we'll return the index, else we'll return -1, right? So this you have to know when and how to use, right? How we discussed currently, right? So this we will be implementing or articulating the same thing in the form of code. This is fine. Now when this can be used, see here, this method is efficient for the unbounded or very large sorted arrays, right? So when it is efficient for the unbounded or very large sorted arrays. Why? Because it quickly narrows down the possible range for the element. So first we'll be discussing this one. First we will be getting the range itself, right? See here, once we find the range, then only we can apply the binary search within that particular range, right? That is the reason this method is efficient for the unbounded or very large sorted arrays, because it quickly narrows down this one quickly narrows down the possible range for the element. So this is fine. Let me come out of this one entirely, man. Now let's do one thing. First let's go with the binary search, this function. So I'll just go with def binary search. So this is fine. So this one will be array, comma, this one left, right, also x, right, for the bound. So now let's go with the standard binary search between indices left and right, nothing but L and R that we have considered as parameter, right? So I'll just go with a while loop here, while left less than or equal to right. So pure binary search this is. So let's calculate the mid first. So this one will be L plus R by 2. This is fine. The next step would be simple if condition, if array of mid. So if it is equivalent to the value x, then what we will do, then we have to return directly mid. So this is fine. What if this one array of mid is less than x? So I'll just go with elif here. So this one array of mid, so this one, if it is less than x, then what we'll do, we'll assign left to mid plus 1. This is fine. Else what we will do, this one r equals mid minus 1. So this is fine, man. So finally what we'll do, we'll return -1, right? So this one will return -1. This is fine. Yep. Now let's go with the exponential search function. I'll just go with exponential search. so this is fine. Now let's go with the parameters array as well as the x, right? So within this function, first thing is, so let me assign this one to the end to length of the array so that we can make use of the variable n, right? So this is fine. If array of 0, the first index, if it is equivalent to the x, then we have to return 0, right? So if array of 0, this one, sorry, one second, array of 0, if it is equivalent to the x, then what we need to do, then we just have to return 0 in that case. This is fine, man. Now we have to find the range by the repeated doubling, right? So this is the exponential search as we had discussed. So we'll start from the index 1 and keep doubling the index, right? So that one we have to do. So first I'll initialize index to 1, I to 1, then let me write the while loop here, while I less than n and array of I, this one less than or equal to x. Then what I'll do, I'll just go with I equals I into 2. This is also fine, man. Next, the final step, so I'll just go with, this is fine. The final step is we have to apply the binary search on the found range. So let me go with a return method. So I'll just go with return binary search. This is fine. So this one will be array comma I by 2. So this is fine. Also min of I comma n minus 1. This is also fine, comma x. Yeah, this is fine. Let's go with the example usage. So this one, let me go with array equals 2, 4, 6, 8, 10, 12. Let me go with 14, 16, 18. So this is fine. Now let's do one thing. Let me go with x equals 14, and also let me go with the result variable. So here result equals, let me call the exponential search function here. So we are making use of the exponential search itself, right? So we are going with the exponential search algorithm itself. So let me pass array as well as the x here, right? So x, we are we should be able to find the 14 basically, which is present at the index 0, 1, 2, 3, 4, 5, 6, right? 6th index basically. Let's print something for the interactive purpose. So I'll just go with here element found at index. So this is fine. Finally, let me pass result here, this one, right? So this is fine. Now element found at the index, so 14 is present at the index 6. This is what we need to get here, right? So before running the code, let me explain you this one once again so that we don't forget this one, right? So this will go, right? So basically we have went with the function binary search, right? So first what we are doing here, while L less than or equal to R. So basically we are repeating until the left index crosses the right. So pure binary search, we need to know this one, right? So this is fine. So this one here, mid equals L plus R, this one whatever we are doing. So this calculates the middle index. We know this. If array of mid means if the mid element itself is the target, then we have to directly return, then we are directly returning the mid element. This is fine. If the target is on the right side, then we have to move the left pointer to right, meaning mid plus 1 basically, this one, right? So else the target is on the left side, and then we have to move the right pointer to left, right? So we have to decrement. Basically we are going with a mid minus 1. This one, r equals mid minus 1, right? So if the loop ends, then if the element is not found, then we have to return minus 1 in that case, right? So this is fine, I believe. This is it for the binary search function. Let's move on with the exponential search, this one function. So first I have written if this is fine, if array of this one 0 equals x. So this one we are checking if the first element itself is the target. If the first element itself is the target, then this one, what do we call, then we are returning 0 if we are checking if the first element is the target here, right? So I equals 1, whatever I have given here, this one, it starts from the index. So basically it starts from the index 1. See here, step 1, we have to start from the index 1 and keep doubling the index, right? Within the exponential search, that's what we are doing here. We are starting from the index 1. So while I less than n here, we are we have to keep doubling I until we pass x on x or the array ends here. That's what we are doing. Accordingly, with the explanation we have went here, right? So then return binary search, whatever I have given here, this one we are searching in the range I by 2 to the I, basically this part, I by 2 to the I, this part, right? So this is fine, man, right? So now let's move on to the main part here. So this one, basically array of this one, whatever we have given the sorted array. This is sorted in the ascending order, 2 4 6 8, see here, right? So this is fine. X equals 14, this is the element to search, basically whatever the element that we need to search, that we have considered here. Nothing but we are searching for the element 4, which is present at the index 6, 0 1 2 3 4 5 6, sixth index. This is fine. Result equals, we are just calling the this one exponential search algorithm, or the function here, this one, right? So we are performing basically algorithm, we are just calling the algorithm here, and finally we are showing the result index. This one has to show the result index, we are calling the result here, right? So we are calling the result here basically by calling the algorithm. This is fine. 14 is present at the index 6. The output that we need to get here is element found at index 6. Let's check the same. So I'll just go with here Python followed by, let me copy the file name .py. See here, element found at the index 6. This algorithm works absolutely correct, means we are getting the desired output, right? So the element 14 is at the index 6 on the array, right? Exponential search function, what it does, it first jumps 1 2 4 8, this one 1 2 4 8 in the sense this one basically, right? So this one jumps 1 2 4 8 when it reaches the index 8. So 1 2 4 8 is not this one, sorry, not the 8th element, basically 1 2 4 8 1 4 5 6 7 8, 1 2 4 8 means it goes with the this one when it reaches the index 8, basically when it reaches index 8 which is basically which is 18, right? So 18 is greater than 14, right? So we are going with the exponential search. First it jumps from 1 to 8, 1 2 4 and 8, right? So this one at the 8th index, what element is present? 18 is present, and 18 is greater than 14. So then it applies the binary search between the 4 and 8, right? So then it applies the binary search between, first it applies the binary search between the 4 and 8, because exponential search we are going with 1 2 4 and 8, right? So 8, for the 8, what element is present at the 8th index? So see here, this element is present, nothing but the 18. So 18 is greater than 14, the element that the index that we require, so the element that we have, or the target element we have, is 14. 18 is greater than 14 here. So what we do, we will apply binary search between 4 and 8. The previous element is 4, we'll apply the binary search between 4 and 8 basically, right? Binary search, what it does, it finds the 14, this one 14 at the index this one, what do we call, index 6, basically. See here, 0 1 2 3 4, 4 means from here we will apply the binary search from here to here, right? So from the element 10 to the element 18 here, right? So this one we will be applying binary search to this one accordingly with the the exponential search, this one algo, right? So 1 2 4 8, then we are applying the binary search, because at the 8th this one, what do we call, at the 8th index we have the element 18, which is greater than the target, this one element 14. So we will apply the binary search with the previous element, nothing but the 4 comma 8. So now when we apply the binary search, so this one, the element 14 is present here within this, what do we call, within this array basically, right? So this one 14 is present at the index 6, totally 0 1 2 3 4 5 6, right? So this one 6 we will return this one as the output. This index 6 is will return this one in the form of output. See here, we are just searching only within this one, right? So the output will be basically 6 here, right? So this is it for the algo, this is it for the algorithm, right? So now we have the complete idea, we are getting the desired output, right? So now we have the understanding of this particular algorithm. So we are done with the searching algorithms, right? So these are the very important algorithms basically, right? So one more thing, you can just go through the linear search as well. So it just goes on searching for every element, so you can just go through the linear search if you want. So these 4 algorithms I have found very important. So you'll be applying this one and many of the problems, basically if you are practicing certain problems or if you are giving contests, so you can just apply this one anywhere, right? So I feel it on that way. These are very important for algorithms. See here, binary search variants, nothing but the lower bound and the upper bound. Binary search on the rotated array, the array when it is rotated, basically rotated twice, thrice or 4 times. So that also we have this one discussed, and the previous one was the ternary search. So how we saw how we can apply the ternary search, how and where, basically how and where or how and when we have to apply the ternary search. Now we have went with the exponential search. Exponential search means we will start from the index 1 and it keeps on doubling, basically in simple terms, right? So then we'll first find the range, basically in simple terms we'll find the range, and within that range we'll be applying the or we'll be performing the binary search, basically. That's what the exponential search algorithm is, right? So this is it for the exponential search algorithm, right? So I hope this is clear. Now let me summarize whatever we have learned so far, right? So just try to remember these 2 or 3 points. So see here, exponential search is efficient for the sorted arrays, right? Especially large or unbounded arrays, right? So this is very important, keep this in mind. So we will be, or we can go with exponential search when we have the sorted arrays, especially large or unbounded arrays. So this is fine, I believe. So it first finds the array, this one, it first finds the range exponentially and then does the binary search within that particular range. Now we have the idea, we have already written the algorithm, we have discussed this one multiple times, we have went with the example usage as well. Now this one we have to know this one at any cost, right? So we know this one. So it first finds a range exponentially and then it does the binary search within that particular range, right? So this is fine. So what will be the time complexity here? The time complexity would be big O of log I, logarithmic I, right? So the time complexity is big O of logarithmic I, where I is nothing but the index of the target, right? So this is the best case. For the best case it would be big O of 1 if the element is at the index 1 itself, right? So we are returning 0 here. That one also we have considered. See here, this one, right? So this is fine. The time complexity is big O of logarithmic I, where I is nothing but the index of the target. In the best case it would be big O of 1 if the element is at the index 0 itself, right? So these things you have to remember, right? Now let's finish it off with this particular algorithm, the searching algorithms. Let's finish it off with the exponential search algorithm, right? So we are done with almost 27 algorithms we have discussed, right? So the topics we are done with is, first we started with the array algorithms, that's fine. String algorithms, we have considered some 10 important string algorithms, that's fine. Then sorting algorithms, very important 5 algorithms we discussed, that is also fine. Searching algorithms, we have discussed 4 very important searching algorithms, that's also fine. And also I insist you to go through this one, linear search, once, so that you understand this one. So before hopping into the binary search, just go through it once so that you will also know what's linear search. That's it, right? It will go on searching for the individual elements, or this one, to find the target element, right? So, or the index of that particular element, that also it can do, right? So just go with the linear search once before hopping into the binary search, that you can do, right? So we are done with array based algorithms, string algorithms, sorting algorithms, and we are done with the searching algorithms today, right? So next we'll be moving on with the linked list algorithms. We'll be starting with Floyd's cycle detection algorithm. So this one we have solved n number of problems using the this one, Floyd's cycle detection algorithm. So this is also known as tortoise and hare algorithm, right? So we have solved many problems in the LeetCode. So in this one as well, Codeforces and the Codechef as well. Now we will be discussing this one, linked list algorithms. There are some important algorithms. There are some, I believe, 5 important algorithms we have to discuss at any cost, whether it may be Floyd's cycle detection, merging the 2 sorted linked lists, reversing a linked list, and detecting and removing the loop, basically, and how to clone the linked list with the random pointers. These kind of algorithms are very important, right? So we'll be discussing about this one, very important 5 algorithms basically within the linked list. So let's finish it off this searching algorithms with this particular algo, exponential search algo. For now, this is it. Thanks for watching, guys.